14 is really, if you're that low, there's a problem.
What's an acceptable range?
I think TEP is using 18 to 22. Yeah. Now, again, depending on the relative humidity in the home and the temperature, it can go up from there. I wouldn't want to see it much lower than 18 degrees. That would indicate that there's definitely some sort of malfunction.
So, but if it's a vacant hot house under 10 degrees outside, the differential will be different, right?
The differential will be very high.
The machine will be running properly. The differential
Exactly.
will be different.
Yeah.
That's something you just have to learn, right?
You have to understand that if the house is extremely warm, you're going to see all that output put into dry bulb drop rather than, because you're not going to remove any moisture during this as it's pulling it down. Eventually you get down to the point where you're condensing, and then your wet bulb temperature will start to go up. If you measured the wet bulb temperature, which you could do with a thermometer with a wick on it, under normal conditions, when the house is down in the comfort zone and we have normal relative humidity conditions, you would find that your dry bulb temperature drop is about 20 degrees and your wet bulb temperature drop is about 10 degrees.
Given that the unit is properly sized and everything is copacetic, is it 30 to 45 minutes a proper time range to consider?
To have the unit cycle?
Yeah.
Again, it would really be determined by when it was sized, if it was just into the next size unit or not. In other words, if a unit is properly sized for the best economical performance, you want the unit to run when you're at your high ambient temperatures, and they're made to do this, to almost run constantly to maintain that temperature. Now, you know, if you're designing at 75, most people don't keep their homes at 75 degrees just because of the cost of doing it. So if you're keeping it up at 78, obviously it's going to cycle. And most systems you're going to find do cycle set at 78 degrees, even on the hottest days that we have. But you're going to find the warmer it is outside, of course, the longer the run cycle is going to be, because as the temperature goes up, the capacity of the machinery goes down. So if a machine is running constantly but maintaining that temperature, maintaining, say, 75 degrees, its sizing is okay. And it's going to give you the most efficient operation, because most of the time the equipment is running, it's running at a demand of lesser capacity than the machine is capable of doing. Yes?
Kind of where people are going with this, I think, is that we may be in a house for 2 to 4 hours, depending on the size of the house. When can we feel comfortable taking our temperatures? A half hour into the running, an hour into the running, 2 hours into the running. When can we start to feel comfortable under most conditions to start taking our temperature?
If you're going to be in the house that long and it's a really hot day and the machine was off when you arrived, the first thing I would do is turn it on and let it run, and leave that toward the end of your inspection. That would give you the opportunity to actually see that the house temperature is dropping. I mean, if it stayed up there at 95 degrees and didn't drop a degree or two while you're making this inspection, then right off you know you have a problem. It's better to have the house in the comfort range when you're making these tests, because that's going to give you more accurate information.
And
Yeah.
how long, if the house is in the comfort range, someone is living there, how long should we let the unit run before we take our temperatures?
Well, if it is in the comfort range, you should at least have it run, I'd say at least a good 5 minutes for things to stabilize out. Depending on the installation, if you've got roof duct involved, then there could be gain in the roof duct and whatnot. You've got to have at least 5 minutes of good stable operation before you take your temperature readings. And then you should have your thermometers in there for quite a few minutes, depending on how quick the response thermometer you have, in order to get a good stable reading on your thermometers before you really try to make any sort of comparisons on temperature rises or falls, depending on which you're
sizing quite a bit, and we don't necessarily size units. By the time we see them, the nameplates are all burned off and
That's done.
they're painted and just completely trashed. Is there any way, without using tools, as Tom puts it, that we can tell the sizing on a unit or whether we're even in the ballpark. We try to disclaim that, but it'd be nice to have some kind of idea.
It's tough because all the manufacturers use different systems on their data plates, and as you say, the latest thing in data plates is a piece of paper with a piece of plastic over it, which in Tucson lasts about 2 years,
Good engineering there.
and it's gone. If you really, what would be helpful for you probably is to get information from the compressor manufacturers, so that you could, that data plate is going to stay on that compressor, and you could find out the actual cooling capacity of the compressor from the data plate that's on it. That's probably your best bet. But with the higher efficiency equipment, you might have a compressor that is the manufacturer's rating at 42,000 BTUs, and yet with the high efficiency machine, you've actually got a 4-ton output. So it used to be you could look at the compressor and say it's a 3 horsepower compressor, it's a 3-ton unit. You can't even do that anymore. In order to be sure of what size you've got, you almost have to have the manufacturer's specifications.
We should just keep disclaiming it.
That would probably be wise. Okay, if you use temperature differential on heating, it's basically the same thing. You're dealing, again, airflow will greatly affect the temperature differential. Humidity has an effect, but it's a little bit different because now the inside humidity, we're raising the temperature and we're not going to be condensing. But the humidity, if it is high outside, is going to start to form ice. So while you're making these tests, you need to make sure you're not in an icing condition, because if there is ice on the outdoor coil, it's going to affect your temperature rise. As ice forms, the capacity goes down. What are you looking for on a temperature rise on a heat pump? Anybody? 10 degrees, 20, 30, 20 to 25? Okay. Remember now that the capacity of a heat pump, in other words, you're taking heat from the outside air. And as the outside temperature goes down, there's less heat available. So the capacity of the heat pump goes up and down in direct proportion to the outside temperature. They rate heat pumps by COP as one rating system, and it tells you the ratio between what you would get with resistance heat. They rate it at 2 different temperatures. One is 47 degrees and one is 7. We don't get down into the 17 degrees very often, so the 47 is probably one you'd be more interested in. I would expect about a 30-degree temperature rise at 47 degrees. And perhaps we can get into that a little bit more. At the higher outdoor temperature, you know, there are people that run heat pumps when it's out up to 75 degrees outside. As the temperature goes up, you're going to have a 40-plus temperature rise. You might be up as high as 45 degrees, depending on how warm it is in the house. If it's a little old lady that needs to keep it real warm, she may be running that heat pump even though it's 70 degrees outside and she's got her house set at 78. So you can get quite a temperature rise if it's warm outside. If it's cold outside, we're getting down into that 30-degree temperature range, 25. You're still going to get about a 15-degree temperature rise. Now this is where, if we stayed at those conditions for a very long period of time, you'd be into having your supplemental heat come on. Again, things like the refrigerant charge being incorrect and so on will affect that temperature rise. So you're going to make your visual inspections as far as the coil being clean, the filter being clean, tight belts, so on and so forth, to make sure that you're getting the air across the coil that you should be. Okay, so now you've determined that everything looks to be correct and you're getting the temperature rise you're expecting. Is the machine performing up to its capability? Maybe, or maybe not. You may have a combination of things. For instance, if you had low airflow in the cooling mode, this would give you a higher than normal temperature decrease. But at the same time, if you were lower in charge, that would compensate for that and probably put you back at about that 20 degrees you're looking for. So now you don't know. You've got your 20 degrees, but the unit may be running at half capacity. And if it's running at half capacity, it's running very inefficiently. So it gets us back to that critical thing of airflow and where this supplemental heater can really be of great importance to your checks. Like I say, in Tucson, we are fortunate in that we do have supplemental heat. And usually the supplemental heater will tell you right on it the kW rating. If you carry a voltmeter and an amp probe, you can measure the kW rating.
How? What do you...
The way you figure out kW with a voltmeter and an amp probe is you actually measure the voltage. And in Tucson, TEP gives us a good consistent voltage, and you could almost bet that it's going to be 240. It's going to be within a volt or two of 240 volts. If you multiply the voltage times the amperage, it gives you the kW. And kW, 1 kW is equal to 3.41 BTUs. Yes?
Many of the listings have a slash and there's two numbers, two
Right.
kW numbers. Which would apply?
The reason they have a slash there is because it's rated at two different voltages. Generally 208 and either 240 or 230, depending on the strip heater. If it's rated at 240, then you could basically take the information on the data plate. In other words, it says 10 kW, and since TEP provides approximately 240 volts, then you're actually going to get 10 kW. At 208, you're going to get somewhat less kW. Remember, there's an unusual relationship there because the resistance is fixed. You know that's going to be the same. So as the voltage drops, the capacity of this heater drops as well. If you applied 120 volts to a 240 volt heater, your actual output would be 1/4 of the rating. Okay, so it drops off and fairly steeply. So if you've got low voltage, you're going to have low output. But on residential applications, we're talking generally 240 volts. You're not going to find 208 out there. And the data plate would be sufficient for using this as a tool to find out what your airflow is. Now, there's a very simple formula for using that information to find out how much air the machine is running. You can take your thermostat and put it on the emergency heat position so that only the resistance heat is running. Let it stabilize and take your temperature rise, and that gives you a temperature difference between the return air and the supply air. You've got your temperature rise now. You also have another known, which is the kW rating. And CFM is calculated by taking the heat output, which is your kW times 3.14, or 3.41, I'm sorry, pi is incorrect, 3.41 BTUs per watt. So if you had a 10 kW heater, you've got 34,100 BTUs of heat being produced by that electric resistance heater. The actual formula, which we can simplify in Tucson here because we are at a good altitude. These numbers this formula is based on standard air, which is at sea level, and we're at whatever, 2,300 feet. The actual formula, CFM equals the heat content divided by 1.08, which is a factor times the temperature difference. We can throw out the 1.08 because our altitude correction factor really brings it so close to 1 you can forget about the difference. So if you just take the heat that's being generated by that strip and divide it by the temperature rise, it'll give you the CFM. Yes, sir?
Can I throw a pointed question in? What
Sure.
about us guys that have to go up to places like Wickenburg or Bose, where they have an irregular generation system? We don't have a fixed power outlet like you do here in Tucson. We have to go over where somebody's working off a generator in their backyard. And we're stuck. How do we...
Your best bet in that case would be to carry both an amp probe and a voltmeter so that you can actually measure the wattage rather than assume that the voltage is such and the amperage is such, because the amperage is going to vary with the voltage. Again, Trish later on will explain possibly how you could do it. You know, you've got a meter put on there, usually, unless you're on a generator, that's going to